What's up, everybody? The Network Berg here. Hope you guys have been doing well. As you might be able to hear, I'm still a little bit sick from last week's stream. Nothing to be worried about. I went to a doctor today. It's not like COVID or anything. It just looks like some extended flu. But I'm definitely feeling a lot better than what I did last week. So we can definitely be labbing tonight. And I did decide that tonight's labbing topic, I want it to be about MikroTik firewalling. I want this to be another beginner-friendly-ish type of lab so that people that are new to MikroTik can kind of see the strengths of the firewall and also its weaknesses, because it's definitely not the best firewall around, but it can definitely get the job done. And there are things in the MikroTik firewall that makes it very, very useful. And that is specifically due to the Mangle rules, which I've mentioned a few times in previous videos, and you can do incredible stuff with a Mangle rule. So something to be watching out for during the stream. We will be getting into Nat, Mangles, the different types of chains, and maybe I'll just have a look at MikroTik's definition of like what the firewall process is, because some people like that technical explanation, but for me it's just, there's the firewall, packets get into the firewall, and then the firewall inspects it and see what's happening, and then decides what to do with this traffic, to allow it, to drop it, whatever's happening. And MikroTik by default, since it is a router, it will always by default just allow mostly everything. Unless you're running a router board and you're running the default configuration, there's no firewall rules. It's just there to forward packets. But that's basically just route traffic from one router to another one. And that's what it gets down to. Now with firewalls, you can definitely lock down what type of traffic can come in and out of your network. There are some best practices regarding firewalls. Like I think there is, they call them bogons and whatnot. It's like a list of prefixes that you can just drop. People tend to drop it with their BGP, but you can also just make sure that you don't accept traffic from bogon networks by using something like the firewall. Or if you can see like maybe I don't want to say a DDoS is happening, but if you can see an influx of traffic suddenly coming from one, or, well, it wouldn't be a DDoS if it's from one IP, but if you can definitely see multiple connections being made from a single IP and you think this is pretty dodgy stuff happening, you can use the firewall to drop that traffic as well. Yeah, and we're going to be setting up a lab in EVNG. This is going to be a fresh lab, so nothing... we won't go into a previous videos thing, although the previous video or stream was pretty cool where we played around with Unimus with network automation, but this is just going to be a fresh lab that we'll set up together and just play around with the firewall. I'll go into my TMB streams folder and then I'll just create a new lab, and I'll just call this MikroTik firewalling, and I'll save this, and let's start up this lab. First, I'll just add a network for my management network, which will be giving us internet out. Link that to my management cloud. So there's the real internet. And then let's add a couple of virtual routers in Eve that we can play around with. And we will connect these routers to each other as well. So let me maybe add like 5 routers. That should be good. I tend to just like giving them 12 Ethernet ports. Don't know why, it's just a thing I usually do. Maybe I just feel 4 is not enough, because sometimes you want to connect some more stuff. And let's just give it the prefix of R. And I'll use let's use version 648.1. Nothing spectacular. I know there's some newer versions, but nothing that's going to change anything how the firewalling works. All right, let's save this up, add these routers. And then I'll just place them in a way that feels meaningful to me or looks decent. Let's put router 4 there, router 5 there. I might connect router 1, 2, and 3 directly to the internet. And this I'll connect on their Ether 1 port, so they just pick up DHCP. Hey, Sarah. There we go. And let's just connect these top routers with some of the bottom ones. I might just put ether 10 to ether 1. All right, ether 10 to ether 1. And let's add some of these routers so they have direct connections to each other as well. So I'll make ether 2 for these top routers just connect to each other as well. I actually wanted to do a whole cool diagram thing with draw.io so that we could plan the network out beforehand, but I think that might have taken too much time. Actually, let's quickly do it, but it's not going to be like a spectacular diagram. It'll just be some routers that we just add here. Let me use the Cisco 19 images because they're pretty clean. I don't think I hit save there. There we go. And let me just find their routing. And I should just be able to duplicate that. Let's just add the same little network. Well, it looked more like this. And I think the reason I wanted to use draw.io is just like to play around with a new plugin that I installed that I saw on a different channel, but I thought it looked pretty cool, where you'll see in a second. I just want to bring up my docs, throw them in here, find a nice little cloud. And it'll be a massive cloud right now, but we can just scale this down a bit. There we go. There's the internet, the great World Wide Web. And now for the stuff that I thought was extremely cool. Although I need to connect on these little dots, which doesn't make it look that cool. Let's just connect these routers to each other there. And we'll make this look a bit neater now. And that kind of looks like our topology. The thing that I found really cool is this plugin in draw.io that you can install from the extras. So if you go to your plugins, there's like a flow.javascript. And this actually makes your diagram look really cool. Like if I just right click and click on the flow, like that looks so awesome. Like, isn't that cool? It kind of just like, then you can see how the traffic flows. I feel like it's a great way to explain something, especially when it comes to routing, because then you can just make it like a different color and, you know, just explain kind of how traffic is flowing. So it gives a nice visual representation. But we're not doing any flowing here. This is just routers directly connected to each other. Kind of off topic, but I just wanted to show that. Let's get back on the firewall portion. So let's start up these routers, but I still need to do a little bit of planning. So let's just assign some subnets between our devices. So I might do something in the 10.0.0.0 slash, just give them a bunch of /30s. These top links are going to be in my 192 range, so don't worry about those. So just the links between the actual routers will be getting these private IPs to connect to each other. And there's a little bit of routing that we're going to have to set up as well to actually get into the firewalling, but it's going to be very minimal. We're not going to be doing anything complex. So let me make that 2, 3, and let's just duplicate. Actually, I should have done this before. I could make it look fancy by doing the boxes on the outside, but I don't want to spend too much time just making it look nice. So let's get a nice .1 and a nice .2. Duplicate .1. So let's make that .1, .2. I think I can just, can I control C? No, that doesn't do anything. That doesn't work the way I wanted it to. Right, dot 1, 2. I don't want to add another node, just duplicating some text. Let's make the middle router dot 1 for both of these top devices. And then dot 2s on the edges. Duplicate. All right, and then we'll also just quickly check what 192 subnets my router 1, 2, and 3 received. So that I can just check on the DHCP really quickly. I can just log into PuTTY, admin blank, and just do an IP address print, or I could do an IP DHCP client print. So 131 is here. I'm going to guess this is 132, but I might be wrong. It depends on what my DHCP server thought was still available. Shoot. Admin blank, no. IP address print. 133, so I was wrong. I could put this at the top, but that looks really like funky. I don't like that, so let's just put it here. This is just to understand where all of these IP addresses are. Admin blank, no. IP address print. 137. I wasn't expecting that number at all, but that's fine. 137. And now in theory, router 1, 2, and 3 should already have internet out. So let's just test that. Okay, that looks fine. All right. So at a base level, our top 3 routers have internet. The bottom ones don't have anything yet. But it's enough for us to start playing around with some firewall rules. And I might just go into Winbox to actually illustrate a bit of this. 131 is router 1. So I'll just log in with admin and blank. Let's just connect on the Mac. There we go. Close all my windows, and let me just quickly go into the IP firewall. But let me just zoom in as well, because I know some people are they feel like my resolution is too high, even though it's only 1080p. I understand if you are watching from a cell phone or a tablet, it might look very small, so that's why I'm zooming in. All right, so for us to be working on the firewall, we first go into the IP and firewall settings. And I've already shown you like what the IP address is on this router, what it received from a DHCP. And this is basically a WAN address right now. But since this is a CHR, it doesn't have any firewall rules by default. And as I mentioned in the beginning of the video, when you start up a new router board that comes with default configuration, it has some very basic firewall rules, but nothing in depth. It's like stuff that blocks I think input traffic on port 1 and some kind of weird stuff. But we'll add some firewall rules here. But before we get into the firewall rules, I must stress you need to understand connections or connection tracking specifically, because the whole point of the firewall table, it relies on connection tracking in order to work. So there's a cool feature on MikroTik that people love using because they think it makes everything faster, and that's called it's fast track. So fast track, it is a pretty cool and neat tool if you use it properly, but don't just think you're going to put in fast track and now your internet speed is going to double or whatever. It just basically, what fast track does in essence is it allows that packet to ignore the firewall or connection tracking. So it can just like shoot through the router or router very quickly. But that also means that you can't apply any firewall rules, because any rules that you might have against packets that are being fast-tracked, it will just not work. So be aware of that. If you are making use of fast-track, the firewall kind of like becomes pointless, especially if you're trying to fast-track everything, then there's no point, right? But the firewall is useful because it allows us to do very cool things. I mean, here you get your service ports. It's relevant, but it's not that relevant. I mean, people tend to just disable a few of these things, especially like the SIP on the MikroTik. The parts that we want to look at is the filter rules, the Nat and the Mangle, because those are the real, I'll say, heavy hitters whenever you're configuring anything or you're making any types of changes. This is really where you're going to be configuring stuff. So you need to also just understand what you want to do whenever you are working on the firewall. Because right now we're on router 1 and there's so many possibilities what we can do with the firewall. Before we add any firewall rules though, let's just go into the filter rules and let's just go through the chains quickly. So we get 3 different chains, and I have made a video before on MikroTik firewalls. So feel free to go through that. It does have a, I don't want to say it's a lot more in depth because the stream's probably going to be a little bit more in depth, but it explains decently like what each chain is for. But on a short note, forward is just for traffic that's going to be flowing through your router. So let's say, let me go back to my Eve quickly. Let's say if traffic from router 4 was going to go to router 5, if those packets are forwarded to router 1, and it needs to forward it either over the internet or to router 2, that would be forward. I've already like put the word in there, but that is what the forward chain is for. So traffic that's being forwarded through the router, it will be impacted by this chain, by these firewall rules that you apply. Then we get input traffic. So this is pretty straightforward. Again, router 1. So let's say each port represents something that could be an input. So let's say if I was coming from the internet, connecting to 192.168.74.131, that's what I'm connecting to. That is an input chain that's coming in to my actual router. So the destination address in the IP header or the packet is my router's address. So my router then understands, hey, this is coming into, it's for me. It's an input chain. It's for me. It's addressing me as a router. So anything that's in input, you can essentially decide, do you want to drop the stuff? Do you want to accept it? What do you want to do with the input chain? And then lastly, output, I think that should be pretty self-explanatory since I gave the other explanation about input, but output is traffic that's leaving directly from the router. So let's say router 1 tries to make a connection to router 2 over SSH. Inside the IP header, it would be router 1's IP trying to connect to router 2. So router 1 is actually making the connection. And that is what an output chain is. So you could effectively restrict what type of traffic can leave from the router. Maybe you want to block certain types of services so that the router can't participate, maybe like an OSPF, or you don't want the router to be able to ping certain things. That is what you could use the output chain for as well. So those are the 3 basic chains that you'll work with in the filter rules. I just want to go to the Nat rules, because the Nat has also 2 different chains that you can use, a source Nat and a destination Nat. And unlike the firewall or the filter rule chains, the Nat chains, I mean, it feels like it's self-explanatory, but some people do struggle a little bit with Nat. And that's fine. It can be a tricky subject, especially if you're new to networking. But in essence, a source-based NAT is for any traffic that you want to change the IP address in the source field of an IP header. Hang on. Let me see if I can open up Google quickly. And let's just go into an IP header quickly. IP header. So let's just open this up. I really don't want to confuse you guys like, hey, this is this. Because I know if you're studying for networking or you're new to networking, I remember when I wanted to study for the CCNA, and when I saw an IP header for the first time, I was like shattered. I don't know what the hell is going on. And I don't want you to become too like frightened in this little block. There's nothing special here. The important bit that I want you to notice is at the bottom there's a source address and a destination address. I just want you to focus on that information in the header for right now. So the header is just basically like something that's put on top of a frame to say like certain things. The protocols are also kind of important for you to understand. Is it TCP or UDP? But the source and destination address is very important in terms of the firewall stuff that we're trying to do now, because this source address, what the source NAT allows you to do, hang on, let me just see if I can put it in the same screen almost. That doesn't seem to work as nice, and now it looks funky. All right, I'm just gonna have to explain like this. Okay, so a source NAT allows you to change the source address to whatever you want to. And this is typically where service providers or even customers or whoever will set up source-based NAT to hide their IP address behind something else so that the internet sees your public-facing IP address. It doesn't see your private address. Because if I was to 10.0.2.1, which is router 1's, let's say, LAN address, even though it's not in this case, but let's say it was, if that was trying to make a connection to the internet wouldn't know how to get back to that private IP because it's a private subnet. But because of something like NAT and source-based NAT, we are able to hide our IP address behind something else that the internet actually understands or how to get to. And that is what, even though 192.168.74 is also a private IP, it's just an example. It could have been a public IP address, and then that's how the public IP, like how the internet could have communicated with us. And that is the essence of a source NAT. And with source NAT, you get two very common actions people use. And that is either masquerade, which you'll see very commonly used. This is actually like the lazy way of doing NATing, because what source-based NAT does when you masquerade, if you specify an interface where traffic leaves out of, so let's say if traffic was leaving over Ether 1, which we know is the WAN, and we apply that, then essentially what the source NAT will do is it will masquerade any traffic that's leaving over Ether 1 as that IP address of Ether 1. But what you could do as well is you could say source NAT, and then you can statically say what you want this to be natted to. So you could NAT this to 192.168.74.131, which is pretty acceptable way of oh, sorry. Hang on, I just need to cough quickly. Apologies. Like I said, I'm still a bit sick. But yeah, so that is what source-based NAT does. It is very important if you are doing a source NAT action that the IP address does exist on the router. If it doesn't exist on the router, the source NAT doesn't like really work or do anything. So just actually, I'm not totally sure about that. I know for destination that is the case. But anyways, let's say the IP address needs to live on the router, and that's how you're going to do a source NAT. And I'll show you guys as well. I'm just quickly explaining like what the chains are doing. And now let's go to the destination NAT. And if you go to those actions, there's just really one thing you're going to do here, and that's called a dest NAT. And what this does is you can then change, if you go back to that IP header, you can change the destination address in the header so that the packet gets forwarded to that IP address. And that is typically used for, let's say services like you've got a router that's internet facing and you want to NAT traffic down to a web server or a mail server or a PABX or something that's sitting behind the router. You can use a destination NAT to get to that IP address, because basically the frames come from the internet. They say, hey, I want to connect to this public IP address, and you say, okay, but on your router, this public IP is actually being NATed down to this .2. Hello internet, but the internet doesn't know about this IP address. It's literally this public facing address that it now connects to. And that's the cool thing about NAT. NAT changes the source or the destination address in the header when it like leaves to the next hop, so that, you know, traffic can actually flow where it needs to get to. Alrighty, Let me just quickly get back on the stream. Hey, Andy. And the last thing that I wanted to go through tonight is the Mangles. And by the way, we're still in the descriptive part of the lab. So you haven't missed anything. We haven't done actual proper setup yet. We're just discussing so far, just some of the logic. But here we get a few more chains, but you can use the forward input output change. You can use post routing and pre-routing as well. So obviously post routing means an action that happens after a packet has been routed, which is very rare to use actually, but there are cases for it. And then pre-routing. So let's say a packet hits the router, hits the firewall, and then you can basically tell the router or the firewall what to do with this packet before it gets sent anywhere else. And this is what makes Mangles like really cool, because you could effectively change how traffic is routed, or you can change, this is a feature that I use quite extensively whenever I'm doing something called route leaking. And it works great. So Mangle is probably one of my favorite features on MikroTik. And there's so much you can do in it, as you can see. You can change stuff like MS says. You can also fast track the connection. You can mark packets. You can do so much with a Mangle rule. Just give me a second. I just need to clear my throat. Thank you. All right. So now we've discussed all of the chains. I just want to see, can we go on to, will MikroTik's TOC have it? MikroTik TOC. Let's just see. It might be on the TOC or the wiki, but we just want to go in specifically into the firewall. Firewall. I wonder what would explain this best. Because I just want to see if MikroTik has the little table here somewhere. And again, the TOC is a great place to like figure something out. MikroTik always has very nice examples on there that can help anybody figure out like what's actually happening. I don't see it there. Is it maybe in the MikroTik wiki? MikroTik wiki. This will take me back to the TOC. Let's just Google MikroTik firewall table. Their image. And this is why I don't like explaining this stuff with there we go. It is here on the TOC, the packet flow. But this is now for the bridging, routing. Here's the firewall stuff as well. But it can get quite convoluted. And I mean, it makes sense, but I kind of hate like flow diagram stuff. Yes, Blender, all my streams are saved and are public on the channel. It's not something that I take away. It's just there, so you can rewatch it at your own leisure. Nothing, I won't just take it away. But yeah, this is kind of also like why I don't like these flow diagrams, even though it makes sense. But this isn't really showing me the firewall flow. There we go. Here's the packet flow chains for the firewall. This is kind of like how it gets to that end decision. So I would highly recommend you come to this manual packet flow. I'll probably just put this in the description after the video is done, so that you can come and have a look at the diagram afterwards. But when we actually get into the lab side, like it'll make a lot more sense, like what's happening with the firewall. So let's get back to Eve and let's start doing some stuff on the firewall so that it can actually make sense, like what's happening. All right, so let's first play around with some filter rules. And I've explained to you the 3 different chains we have: forward, input, output. So let's do a few input chains, or let's make an input chain. So input again is for traffic that's coming into the router, and there's various ways or fields that you can like populate. I mean, you can specify certain protocols, specific interfaces like in. It would be silly to specify an out interface in an input. Let's try and specify an out interface quickly. It will probably give us an error. There we go. It's giving us an error because you're doing an input chain, but it's not traffic that's going to be leaving the router. But if you select an in interface, so we can say in ether 1. Actually, let's say in ether 2, because we know ether 2 is connecting to router 2. Although there's no IPs yet, but we'll fix that up just now. And what we can say, action, we can reject. Reject with, this is pretty cool. If you reject traffic with the firewall, it can actually send a message back to the host that's trying to connect to you. And here you see it's mostly with ICMP. It's just a nice way to let people know that you're not allowing like ICMP to your device, because sometimes people do like a trace route and the trace route stops and they freak out and they say, this is a problem, I've got like a star here, and then it continues again. And many of the times it's because people just don't allow you to see those hops, which is normal in an ISP network. All right, but let's do this. Let's do an ICMP admin prohibited, and let's select the protocol here as ICMP actually. So we're doing an input chain for any ICMP coming in on ether 2 to be rejected with an ICMP admin prohibited message. So now I've created the chain, it's set up. So all that I need to do now is actually assign IP addresses quickly to those interfaces. So ether 2 is 10.0. What is it? 0, I think .2/30 on ether 2. And I'll quickly do router 2. Just via the command line, so it's a bit quicker. So I'll do a IP address, add address 10.0.0.1/30 interface. Ether 2. I've been considering joining Twitch, to be honest. Because I think it is a nice place to stream as well, and I mean I'll be blunt, like there's no real let's say I'm considering stopping streaming to make full-time videos again, because I get more engagement out of full-time videos than what I do out of the streams on YouTube. And it's not a bad thing. I love streaming and I love speaking with you guys in real time, but for my channel, it feels like my channel is, you know, I don't want to say not getting as many views as it used to, but there's definitely been a shift since I've started streaming and not making like videos. So I think maybe I'll stream on Twitch as well and just make video content on YouTube. But we'll get on that later. All right, let's just see. Can I quickly ping 10.0.0.2? Let's see. What can you guys see? So I'm doing a ping now to 10.0.0.1, which is router 1's IP address on Eve. But the cool bit is I'm getting a status message admin prohibited. So that ICMP isn't actually, it's not being dropped, it's getting rejected. And it's just so that it can tell the other router, hey, admin prohibited. And if I ping this from, we can do it from my own computer as well. This is going to be so cool. So let's go back onto that first MikroTik. And let's be very lazy. I can copy the same rule, but I'm going to go to general. I'm just going to change my in interface to ether 1, which is what I'm connecting over Winbox at the moment. Although I did connect on the MAC address, to be completely honest. All right, let's see. Can I ping 192.168.74. Was it 131? Destination net unreachable. Okay, I just want to very quickly stop that. There we go. Okay, I'm not getting the same message. I was actually hoping to get a cool message there. Let's see if I can change it with something else. Let's do ICMP network unreachable. Apply that. Nah, I still just get destination net unreachable. No, but I just change it to that. Net prohibited. No, it's just going to give me, I think, the same message. What more? Prohibited? No. Okay, cool. So from Windows, I just get the same message, but you get the point. Now, nothing can ping my IP address. And this could be quite nice because I don't know if you're aware, but on the World Wide Web, there are these I don't want to say scary people because most of them just use AI and bots and whatnot. But these things will relentlessly be scanning public IP addresses to see if they can find like vulnerabilities and to get in. I don't want to say they're doing it to you now, but if you leave Wireshark maybe running long enough on an internet connection, you can see how many weird connections are trying to get into your router. And it's scary. I mean, if you leave a MikroTik for a week and you log in, you might see a lot of invalid login attempts. And this might be due to people that they first see if they can ping the device, and if they can ping it, that means that there's useful information that they can get off of it. And then if they can, then they'll start trying to log in and hack you. It's not like it's happening the whole time. It's just like it is an occurrence, and that's why it is useful to just make sure you understand how the firewall works and how you can block things. So now you can block ICMP, which is great, but let's see if we can maybe block people from accessing our MikroTik over the internet. So what I'm going to do is I'll just add another input rule, and what I'll do is I'm just going to set the source address to 192.168.74.0/24, which is my management network. So this is my cloud here to the internet, which is actually the wrong way of doing this. Let's actually not do that. Let's make it 10.0.0.0/8. So that's anything from these private subnets. We're going to say from these subnets. I'm not going to specify any interfaces now, because now then it can be applied to all interfaces. If I do it this way, it will work on an IP level, but you could do something like you could create an address list in this advanced tab, and then you could specify in that address list like what can actually connect. Although I don't see like an in and out list here, so maybe I'm wrong in that front, because there's a bridge list. All right, no, I don't see that. All right, but let's just say anything from our private subnets will be allowed for management access. I hear you, and I agree with that as well. All right, so for these I will accept, but we do want to kind of set a port. So let's say anything on TCP, and let's say the destination port is 22, which we know is SSH. So let's apply that. And now we've got a firewall rule at the very top, and there you see it automatically puts accept thing at the top for us. But you can change it. I think you can. Actually, no, it doesn't seem like you can. But I wanted to say you could potentially move the sequences around for what is being referenced first. But in this demonstration, I can't. All right. But what I want to do is actually block SSH from the internet. So I'm just going to say input. And there's multiple ways to do it, but this is now through our firewall. So here I'm just going to say anything else. So I'm not even going to specify source address. That's connecting on port 22. I'm just going to drop. I'm not even going to reject that. I'm just going to drop that. All right. So let's quickly see if I go from my actual machine. If I go to PuTTY, can I connect to 192.168, 74.131? Let's try and open that. And what I want you to also just check is these packets. We can actually see if anything is hitting this firewall rule. And in this instance, we can see in our drop rule, traffic is hitting. So this SSH connection is actually now going to fail, which is perfect, because now that means this hacker that's sitting there that's trying to SSH to my router for management, he can't do that anymore. But on my network, which is now part of this 10.0.0.0 whatever subnet, if I go on to PuTTY to router 2 quickly, and if I try and SSH, I think I just need to do system SSH to 10.0.0.2 with the user as admin, I can connect, even though it looks funky, but this is more of an Eve issue than what it is with the firewall rule. If I just quickly restart one of the routers, I'm pretty sure it will work fine. Actually, let's try and connect to router 2 via PuTTY directly instead of Eve. What is router 2's IP address again? Let's just make sure. IP address print 133. So I'm just connecting to router 3 quickly. Let's see, can I ping? Well, I can't ping 10.0.0.2 because we've got that ICMP rule. But let's just do the SSH again. And there, I've SSH'd in, no password. And if I do an IP address print, you'll see I am on router 1 now. It's just all of the routers' names are MikroTik at the moment, so because we haven't changed the system identity yet. But cool. Hang on, sorry. I really dislike being sick and coughing into the microphone, so just give me a sec. All right, cool. And if we look, we can see how many packets have hit our rules. So we've got some pretty funky, cool rules that's dropping ICMP traffic. We're dropping SSH traffic to our router from the internet, but we're allowing SSH traffic from our LAN addresses. So I think we've kind of mastered the input rule. Now let's quickly see if we can figure out the output rule. But just before I leave input completely, I just want to stress again, there are plenty of fields that you can fill in here. So you can be very specific with what type of traffic. This is like the great thing about the firewall rules, is you can be very granular about it. You can specify to a dot like what you want to drop or what you want to allow. It's not like this big net that you're just throwing. Okay. Let's see if we can master something in the output chain, because we know input is for things coming into my network. So output is obviously traffic that's leaving my MikroTik. That's going to be leaving my router, going to router 2 or to the net or to router 4. So let's quickly see if I do let's just run a continuous ping from router 1 to 10.0.0.1. And this might time out, but I think because of my ICMP. So let me just quickly disable that rule. And let's go back here. And that sucks because that ICMP reject rule, because the ICMP technically can't like echo back. It's that's why that was failing. Because that's how ICMP works in a nutshell. It's like an echo request. It sends, hello, are you alive? And then the other guy says, yes, I am alive. And then it like determines how long it took for them to communicate with each other. But if one side is rejecting it, then the ICMP is just going to fail. All right, we're pinging 10.0.0.1 now, which is router 2. And we are first just going to try and put a stop to that. So let's go into our firewall. Let's do an output chain. We can do ICMP again because it's very straightforward. But now we're not going to specify an in interface, we're specifying an out interface. And here I'm going to say traffic that's leaving over Ether 2. I want this to be dropped. And then I can apply that. And then if I go back into my router, I should actually, it should actually be dropping. For some reason it's not. Oh, I created a fast track, man. I wanted to say when I saw this special rule that something wasn't right. Oh, you can't delete that. That's fine. Let's just update this and let's go back to our ping. Let's see if we can run it now. There we go. Packet rejected. So now we are not allowing traffic to go out from router 1 to router 2 because we've rejected that. We're stopping, we're putting an end to it. And like I said, this can be, it's a double-edged sword because ICMP is so useful for troubleshooting. So if you start doing stuff like where you disable being able to ping from a router, like you might run into some issues when you want to troubleshoot. But it could be useful for, like you see, there's various different protocols that you could use here. So it could have been, let's say I was running OSPF over the network. Let's just see, is the OSPF protocol here? There's OSPF. So here I could have also like dropped OSPF packets from leaving over Ether 2 because maybe I don't want Ether 2 to be able to create an OSPF network, you know, to make that adjacency to learn routes and stuff because I'm learning it over a different interface or a VLAN or something, and I just want to make sure I'm not accidentally breaking things. So that could be a very good use case of using the out filter or the output chain. What else can I maybe do with the output chain? I mean, it's pretty self-explanatory what the input and output chains are doing. I think let's do the forward chain now, to be honest, because I think you guys should understand what output is doing and what input is doing. So again, as I earlier explained, forward is traffic that's traversing through your router. So it's going from router 4 to router 1, but router 1 is not the destination. Your destination is maybe router 2 or router 3 or router 5. It's somewhere else. So it will flow through your router. It's traffic that's going to be forwarded. That is a personal question, but I mean, you can redistribute the default route over OSPF. I can't see any drawback to doing that. I know some ISPs that do that, so if you're just using MikroTik at the backbone, there's really no issue with redistributing a default route using OSPF. Hang on, I just need to clear my throat again. Sorry, guys. It sucks being sick. All right. So, forward chain. Let's first look at the diagram and think of what we want to forward. So, let's maybe just make this connectivity between router 2 and 4 just to make this quickish. So, I'm going to go into router 4, just quickly add some IPs and very basic static routes. So IP address add address 10.0, what is this? 2.2/30 on its Ether 1. Then I'm just going to do a default route out. Gateway 10.021. And I just need to do some config on router 1. So let's just add an IP address 10.021/30, and that was Ether 10. So let's just apply that. And then I just need to do a little bit of config on router 2. So on router 2, all I'm going to do is IP route, add destination address 10.020/30. Gateway is 10.002. All right, I just quickly want to see, can I ping 10.0.21? I can. Can I ping 10.0.22? I can. Okay, that's great. So now router 4 and router 2 can communicate directly with, well, not directly, it's obviously going through router 1 to speak, but we know that ICMP is working. So now we can do something cool by just going on to router 4 and I'll run a continuous ping to 10.0.0.1. I don't want a minus T, sorry. We'll leave that running. And I'll leave it running on router 2 as well, to router 4. And let's just quickly play around with the forward chain. So in my filter rules, I'll do forward, and I can specify like what I want to do. So I can say anything with the, let's say anything with the source address of 10.0.22, wanting to go to 10.0.0.1. I could specify an in interface or an out interface here, because since it's forward, I think you can use either interface lists, but we won't use an interface for this. Oh, here's the interface list. It's on the general tab as well. So I thought for sure they would have put it in advanced with the address list, but that's fine. And what we'll do is we will just drop that, hard drop it. Let's apply that and let's see the outcome. So I'm just going to go to router 4 and now we're getting timeouts. I think I should have the same on router 2. Yes, but that's because again ICMP needs an echo to work. So without the echo, we're going to have issues. All right, I'm just going to disable that forward rule. Then our ICMP should start working again, which it did, which is perfect. And it doesn't just need to be ICMP, it can also be like management stuff. Because what I could do was, let's say, again, anything from 10.0.22 going to 10.0.0.1. And here we could again say TCP. Let's do SSH again. Actually, let's do Telnet 23. So now I'm just going to drop any Telnet requests from router 4 to router 2. So here is router 4, still able to ping router 2. But if I do a system telnet to 10.0.0.1, it's just going to hang now, which again is a great way for management to make sure, you know, if I put that on my internet facing interface, then I would know that it wouldn't like work. And we could, like I said, specify the out interface. So here I could say, let's maybe say out of ether 2, since we're being very granular now. So let me go back to router 4. If I do the telnet to 10.0.0.1, it fails. But let's see if I ping, is it 192.168.74.1, I think 133. That was router 2's public address. If I do a system telnet to 192.168.74.133, does that work? That I can connect to. Admin blank. And there we go. I'm on router 2, but via the internet. But again, you probably want to reverse that. You probably want to stop SSH from going, or telnet or whatever, going out from over the internet and allow it over your Ethernet ports. It's just for like security. There's no other reasons why not to do that. All right, and again, you can use the forward chains for any, it's like any traffic that's being forwarded, you can do with what you want with the firewall rules. And that is so cool. Again, we could, if it was a forward request for anything else in this protocol list, we could do what we wanted. We could accept it, we could block it, we could reject it. Another thing people tend to like to do is maybe put it like in a list, and then they could do stuff with the QoS with that list, or with other firewall rules. Let me give you a quick example. So here's a chain forward. Let's do port 22 now, going to 10.0.0.1. And remember, the general and advanced tabs, these will be for information that's in the packet, like things that the router will look at before it will do an action. Extra I've hardly used. I think I've used extra maybe with PCC, but other than that, I haven't really used the extra that much. Action. So what we could do is add to destination source, or add destination to address list, and then we can add an address list. So so this is actually quite useful for, let's do something different. Actually, wow. Let's create a new filter rule. I'm not going to do forward, I'm going to do input quickly. So we'll say input, and I'm going to say any SSH requests we're going to add to a source address list. And then we're just going to say people trying, I don't know if I can use hyphen, people trying to connect to me. I mean, it doesn't have to be that name, but you'll see like what this is going to do in a second. So that rule that we just created is basically going to look at any connections coming to my router on SSH, and it's going to put it in a address list in here. And an address list is effectively like, it's just like an object in the router where you can assign addresses to. People tend to use this for mass rules in the filters, because like you saw, if you go to this advanced, there's a address list that you can put here, and there I can specify people trying to connect to me. So this is going to make sense in a sec. So on router 2 system, let me try and SSH again to 10.0.0.2. I can, and I just want to go back to that address list, and I was half expecting there to be an address list entry there. Let me just check if I made a mistake anywhere. People trying to connect to me, that looks fine. Let me just quickly try and connect directly over the internet as well. 192.168.74.131. I think I've got that blocked on the firewall rule still. Just let me disable that rule. Disable that. Disable that as well. Yes. Oh, I didn't specify a username there. So admin at 192.168.74.131. All right, I'm in. And let's go to our address list now. Now I'm getting address lists. The reason I wasn't was because I had this overriding rule just above it that was allowing all access from that subnet. So it wasn't adding it to that list. But the nice thing is, now that I've got a list, I can effectively see who was trying to SSH to my router. And this is actually really useful for if you want to catch those people trying to connect to your device, because this will now give you like a space where it saves their IP address that they tried to connect from, and then you can potentially block their IPs from connecting in the future, or you can do some research and figure out where these IPs are hosted and ask their ISP, hey, I'm getting like weird requests from this public IP. You guys maybe want to have a look at that. And I mean, this is quite nice that you can put these IPs in a list, but then you can also do things with that list. So I can say anything input that's coming from people trying to connect to me, reject that. I just want to see where it's this one. All right, cool. So let's try and connect again over management. I just want to see that I actually, no, let's just specify 22 as well. Or let's specify Telnet. So let's say those people, they'll be able to connect over SSH right now, but Telnet we're going to drop from them. So on router 2, let me see, let's just make sure, can I still SSH system user admin address equals 10.0.0.2. Okay, I can still SSH. Can I telnet system telnet 10.0.0.2? And let's see, is any traffic hitting our policy? And yes, it is, and it's being blocked. Cool. So now we actually used an address list to block things, and you don't need to, like I said, generate an address list by manually adding, or not manually, I mean dynamically getting it by having a rule like that. You can also add an address list here by giving it a name or adding it to that name, and then you can statically specify an IP address. So this is also nice if you want to do stuff like Google 8888 and Google 8844. Because if I do that, now I've got another address list called Google, and it's got Google's IPs. And then if I always want, I could always now say, I might say destination port. I know DNS uses TCP and UDP, but let's just do TCP for now, 53. And we specify the destination address as Google. We'll accept that. And I will apply this. And then I'll add another rule. Wait, that was now for Google. And this is a forward chain now. So this is traffic that's going through the router, which is fine. And then let's do another forward chain for protocol TCP to port 53. So anything else on port 53, we're going to drop. So then what I want to do is, this is actually good exercise. So let's go back to our topology. From router 4, I'm going to do a ping to Google, but it's actually not going to work. And I'll tell you in a sec why, but we're going to kill two birds with one stone, so to speak. I know some people don't like the saying, but it's a saying. It's not like to be taken literally. But let's see, can I ping 8888? I can actually ping 8888 from router 4. I was actually expecting that to fail, but who knows? Awesome. All right, so I'm pinging Google's DNS server. Oh, I actually need to try and telnet, I think. So let's do a system telnet 8888 port 53. It's actually going to, Google's going to close that. It's actually not a good way to test it. Let's just change the protocols quickly. So instead of being 53 for DNS, but we could have made it 53 for DNS so that people could only use Google's DNS. So they can't use somebody else's DNS to try and get through some stuff, because this is something in the industry as well where they might use like a proxy DNS, which let's say you're very specific, you block certain IPs and stuff. But then the user is smart enough to put in a different DNS server, and this DNS server makes use of different IPs to get to that services that the user was not supposed to access in the first way. This is how you can stop that, because now you can block DNS and just allow DNS to Google or your preferred DNS server or your own DNS server, you know. But I'm just going to change this now for ICMP just for the sake of to make this work. So let's apply that. And this I'll change to ICMP. So let's go back to router 4. And I ping 8888. I can. And here I'm dropping all ICMP out actually. So let's see, can I ping 1111? That I can still ping. I wonder if the policy, if it's actually hitting this. Now here I'm allowing all. Okay, but this is to Google, which is right, because I'm allowing anything to Google for ICMP. And my second ICMP is being forwarded, should be dropped. So this looks good to me, but there's definitely something still wrong. Tracer 1111. Right, so this is going out correctly as well. I'm going to run this ping to 1111, and then we're quickly going to figure it out by just going onto our firewall. And remember this connections tab I mentioned in the very beginning, which is doing connection tracking, which is essential to make use of any of the firewall services. We should actually see this connection here. I'm having a look, but I'm not seeing an ICMP here. Because there's 10.0.2.2. That's also a fair statement if we try to shift the sequences around. I just want to disable this rule quickly and see what happens. Because there it's still being allowed. Even though I am saying anything being forwarded via ICMP should be dropped. But my biggest concern is that I don't see the traffic in my connections. And I should be seeing that. Let's just continue running this ping. And then I might do another connection. Hang on, let's do this. Let's do this. Tool, Ramon, set enable, yes. And we'll enable Ramon on router 1 as well. This is just so we can quickly connect on one box on router 4. Because I want to have a look at that connection tracking as well. So we'll connect onto router 1, connect to Ramon. And I should have the other router here. This is router 4. So also just zoom in here. Close all my windows and let's look at our IP firewall here. Go to my connections. And I should probably just run my ping again. Yeah, I'm definitely on the correct router because router 1 should be how router 4 breaks out to the net. I just want to have a look, see. The thing that's like funky to me is, oh, I do have a source NAT out. No wonder this was working earlier. Let me just, even though this isn't like wrong, but I recall that I added a source NAT earlier just to kind of explain how NAT works. And this is why I could get out to the internet. So now router 4 can't get out to the internet because it's, being broken. So let's quickly do what I wanted to do, and that is I wanted to add like a very basic NAT rule just quickly. So source-based NAT, which I'm going to say anything that's going out of ether 1, and I'll do that DOM masquerade rule. So let's just apply that. So now all traffic will be masked. All traffic will be masqueraded out as 192.168.74.131 to the internet. Now let's see, can I ping 1111 again? Ping 1111. All right. That's looking more promising. Let me just re-enable that other rule. So let's see, can I ping 8888? All right, so even that's failing now. Even though our masquerade rule is fine for masking the traffic. And there I see the connection going to 8888. Can I actually see the traffic to 111 now? Because it's hypercritical for me to sorry, it's just I really want to see this connection in the connection tab. If I look at my interfaces, I might be able to discern a bit better by just quickly doing a torch on ether 10. All right, I can definitely see that it's trying to connect there, and we could drill that down just to the ports and the protocol. So it is protocol 1 ICMP, which is 100% fine. All right, let's just stop the torch. So traffic is definitely flowing through this router out to the internet. I'm just not totally sure why the NAT is not doing its thing now. Just going to disable that. Source NAT, anything going out of ether 1. Let's just create another source rule again. 192.168.74.131. I might just have to bounce one of these routers quickly, but it's fine. I'm just going to add the basic masquerade rule again, out of ether 1, masquerade that, apply. Just one more test from router 4. Ping 8888. Okay. All right, but there is routing currently. I'm just going to stop router 1 and bring it back up. So nothing fancy. And I might just restart router 4 as well. And we'll connect to both of them again on Winbox just now. Just going to close these other windows. All right, let's just see. I should have a neighbor back up for 131 shortly. Here we go. There's 131. Let's just connect like this. Close all windows. Just make sure, can I actually ping out from here? Because that's already a big issue. It can potentially be bad, Jack. I mean, it depends on the requirements. Because I get what you're doing, but do you really need to bridge them? Because what I'm assuming you're doing is you've got a bridge, and then you're allocating a public IP to the bridge or whatever, and then the customers like break out with this public IP that's on the bridge. Sure thing, Blender. Let's quickly, because they are identified on EvenG. But we can just do this better by just going quickly and do system identity set name R1. So that people don't get confused which one is which whenever I'm on Winbox. System identity set name R2. I haven't even touched R3 or 5 yet, but I don't even know if we're going to have to be honest. Admin blank system identity set name R4. Okay, I just wanted to set those. First things first though, me not being able to ping out to Google's DNS from router 1 is already like a problem for me. So I just want to see, is there anything that I set up here that might be causing issues with the ICMP? What output do I have here? That's just for the OSPF. Let's add source to whatnot. So any ICMP being forwarded. Okay, but this looks like. All right, now I can actually sequence it as well. I don't know, hang on, let me increase the size. Because it was weird earlier, I couldn't like move any of the rules around. But just to make sure everybody understands, like firewalls work on a sequential level as well. So if I like toggle this, like, that's why it wasn't working, okay. Because firewalls list rules from top to bottom, and then it will decide like how it's actually, like what is actually gonna work or not. I think, let me just throw that at the top quickly. Let's see, can I ping now? No, I wanna do that. IP route print, let's just make sure I've got a default route out. I do. You know what, to oversimplify this, let's just quickly disable these policies and go back onto our terminal. And can I ping out? I can ping out. So we definitely know there's a rule in here that's causing big issues for us. So this is like amazing for us. Hey Gavin, thanks for the coin, I appreciate it. So there's definitely an issue here with one of the firewall policies. And this is again why I love the live stream, because we can get into situations like this, which is more applicable to real life, because me just showing on a video, everything's working great. And then you run into issues, it doesn't help you that much then. So ICMP is being blocked by something. So we've got a general for traffic being forwarded to be accepted, and then we're dropping, I just want to check, we've got this destination address as Google for the accept, and then anything else we are dropping for ICMP. Oh, okay. Now I kind of know why that's failing. Okay, so remember earlier in the video I was talking about the ICMP being an echo. So here I've got an input chain for anything that's coming in on Ether1 to be rejected. So I'm pretty sure that would definitely cause a little bit of an issue if we ping Google. So let's just see if I'm right. Let's ping 8888. There we go. It's failing. Let me disable this one reject rule. And let's go back to our terminal, ping 8888 again. Now we can ping it. Fantastic. So just to be clear, like the ping was failing because I wasn't allowing ICMP back on Ether 1. And it would have caused us some issues from router 4 as well, because that public IP address like would be what was going to be referenced. Cyvera input comes before forward. So if you look at the sequences like this, then in theory, I guess, but basically all of your accept actions come before all of your dropped or reject actions. So I think that's more applicable. Like things that you accept would be at the top and things that you're rejecting would be down on the list. And if we look at it at a sequential level like this, we can move things around if we want to. In this case, it wasn't being forwarded. So in this specific case, earlier in the stream, I actually rejected traffic coming in on the router on Ether 1 to be rejected. And because of that, it was actually affecting my my other rules, because even though I was natting traffic out and all that stuff, there was no way for, let's say, the internet to echo back to me to tell me that the ICMP is live, and that's why we were getting a drop in the packets. But let's leave that running. I just want to jump back on router 4. So let's connect to the Roman. Get onto router 4. Yes, exactly, Blender. So the ping was there. The router was able to send out the ping, but it wasn't like allowing the pong to come back in. And that was in essence breaking the ping. This isn't the right router. This is router 2. Let me just reconnect quickly. Connect Roman. Did I put Roman on router 2? That's wrong. That's definitely wrong. Let me just quickly put it on router 4. So IP, no, not IP, tool, set, tool Roman, set enable, yes. And now we can just continue as per normal. So connect to Roman. Here's my router 4. Let's zoom in. Let's open up a terminal from here. And let's see, can I ping 8888? No. Can I ping 1111? No. But let's leave that ping running to 1111. Or actually, let's leave it running to Google, because that's what we want to allow. Let's go back to router 1. Let's look at our rules quickly. So we've got some rules to do the ICMP. I just want to see. So anything being forwarded for ICMP to Google should be accepted, which is right. Is my Nat Rule working? It is. Do I have any connections? Yes, I do. So there's my connection to Google, which is 100% right. So I potentially have another rule somewhere breaking something, although the connection is being established, which is good. 8844. Let's just make sure we don't have anything set up on router 4 quickly. No. I'm just going to change this NAT quickly to source NAT 192.168.74.131. Let's check on router 4 again. I did Alt-Tab. Okay, I'm just going to leave that running. And then what we're going to do is we're just going to disable a few of these drops. Oh, this is definitely going to cause an issue. There we go. What I don't get is we've got a Google address list here, and it should be the 8888 and 8844, which should in theory be first, right? But that doesn't seem to have been the case. So what I'm going to do is, wait, my ping is timing out again. Let's just do the sequences like this again. And we've got, there is a forward drop somewhere. This one. It's dropping all ICMP out. And that should be below this one. So that doesn't make any sense, right? Because right now, let's do this. So instead of referencing the address list, which was that Google, let's remove that and let's just specify the destination address as Google's IP, and that we'll accept. And then anything else we can say will drop. I just want to see if this works. So even that is actually not happy. And this is actually not correct, because in essence, the sequencing looks correct. My destination address is correct. What have I not got that's correct? Let's maybe be a bit more granular. And let's say anything that's coming from 10.0 to 2, going to Google's DNS on ICMP, we're going to accept. And then anything else could be dropped. All right, even that's failing. So I've got one more way that we can fix this. We're just going to delete that rule. Ping's running, ping's fine. And then what we're going to do is we'll say anything that's not Google, block or drop that. All right, so even that is actually causing issues. It has to be something with the sequencing, because I just want to go to router 1 quickly and let's see, can I ping Google from here? I can. So I wonder if this has to do with our Nat rule though. Let's quickly update this. But it should still work, because now we're just essentially saying anything that's not, this is an inverse rule, by the way. So on the firewall, this block here, if you click this, it creates a little exclamation mark. And then it basically means anything that is not, so that isn't. So here I'm just saying anything that isn't Google. So obviously then all the other stuff for Google should be allowed, right? This is definitely forward. Let's see if I can specify the in interface as Ether2. Okay, that works. But I don't see why that would have to be a requirement. All right, I'm gonna remove, actually I'm gonna keep the in interface, but I'm gonna remove this destination address. I'm gonna keep that as accept. Then we'll set the destination address list as source. Well, not source. The destination address list is Google. And I can actually do this as well. Oh, thanks, Gavin. Appreciate that as well. So I'm not sure if you missed it, Jack, but the tick boxes is just to inverse a rule. So basically just to say is not. Now, Ether10 is not my WAN. So if we look at the topology, Ether10 is going to router 4. Ether2 is going to router 2, and then Ether1 goes out to the net. I'm just not sure why I have to specify my in, because right now what we're saying is on router 1, we're saying anything coming in on Ether10. What we could do is say anything that isn't Google, we want to drop. So let's just try that. And let's see, can I still ping Google from router 4? Yes, I can. Can I ping 1.1.1.1? No, I can't. So that firewall rule works fine. That's actually doing the job perfectly. But what I want to do is essentially have two rules. So let's just remove this inverse. Keep this as accept. And then let's say anything else I want to drop. So let's copy this. So anything else for ICMP, we will drop. Let's see if that actually takes or not. All right, so this also works. So I can still ping Google, but I cannot ping 1.1.1.1. And the only thing we've changed is we've specified an in interface. So it kind of looks like the firewall needs to understand as well when we do a forward chain, which interface the traffic's either coming in or going out of. Let's do a slight tweak here. I want to do something with an address list, but instead of like an in interface, let's make this an in interface list. And what I'm going to do now is I'm just quickly going to go to my interfaces, go to interface list. So Ether 10. Oh wait, I need to first click on this list button. I don't know why. I don't know why. LAN interfaces. Let's just call it LAN. Let me apply that. So here's a list called LAN, and I'll put Ether 10, and I'll put Ether 2 in there because those two interfaces go to my LAN routers or whatever. And what we'll do is on the firewall rules, what we'll do now, and instead of just specifying an in interface, we'll specify an in interface list as LAN. And what I would like to do is on router 2, I just want to push Google and I think it's Cloudflare or Cloudfire. This is 1.1.1.1. Let's do IP route add destination 8888 gateway 10.0.0.2 and do the same for 1.1.1.1. And let's see, from router 2, can I ping 8888? I can ping 8888, which is perfect. Can I ping 1111? Can't. Okay, perfect. So this rule works better, but we had to specify our incoming interfaces for this forward chain. I would have imagined you wouldn't need to do that, but it definitely seems required, especially with this ICMP protocol we're using here. Yeah, cool. Very basic filter rules. Okay, so that about covers filter rules. I would like us to now get into Nat. So before we do the Nat, does anybody have any questions about the filter rules that we can try and answer now? No, of course, Jack. You can definitely, this is exactly what EVE-NG is for emulation. You could put your WAN IPs on an interface here. You could replicate your entire infrastructure's configuration on a virtual lab, and then you could play around without actually breaking anything. I do a lot of labbing like that. So yeah, you could do that. You can add your public IPs to a WAN interface or multiple WAN interfaces, and then figure out how you're going to deliver the service to your customers. This is why EVE-NG and even GNS3, any network emulator, is very useful. Water. Okay, let's proceed. Well, if you want to do that on an emulated environment, what you could do is you could also import Windows 7 machines or something in EVE-NG, and then you could test from those Windows machines as well and see what happens, what people actually see. When we should use input chain and instead forward. Okay, so maybe let's do it this way, just to explain, because now I can use that fancy stuff that I wanted to chat about earlier in the video. Not fancy stuff, but I'm going to use some cool flows on this diagram, because this kind of looks like our network, right? So what I'm going to do is, let's say this is from the internet, that goes in there. Let me just remove some of these connections which aren't relevant, just so that I can properly explain each chain. Maybe let's connect something like that. All right, so this router is router 1. That's the same one on the EVE topology. Now, the 3 different chains we get is we get input. And input, I'm just going to mark with a different color quickly. So let's say input is this nice orangey color. But that's the wrong arrow. Sorry, let me just redo this. But now that arrow's orange anyways. Let me just delete that. So let's say this is the intranet, and you are sitting on the intranet and you want to manage this router. That's router 1. And this is your connection going to the router. It goes to router 1. Now I'm going to change this color to orange. With that nice arrow there. And then if I do this flow, it looks cool. Now I'm sitting at the internet. I'm connecting to router 1 on its address, on its IP. It's the IP that's on router 1. That is the input. That is traffic that's coming into the router. It doesn't need to be from the internet. It could have been traffic from router 4 going to router 1 as well, where the destination is router 1's IP address. So that is input. Output, let me just use another arrow here. Let me make this a bluish color. Give this a nice flow as well. So output is traffic that's going from the router out to wherever. It doesn't need to be the internet. It could be one of these other routers as well. But the source IP is it's coming from the router. A good example is if I go into Winbox, and let's say I go into my DNS servers, and I put in a DNS server as 8.8.8.8, and I apply that. Sorry, I didn't apply it. That means the router will connect to 8.8.8.8. So maybe if I go into my firewall again, I look at my connections, and let's say, because there you see there is my router's IP connecting to 8.8.8.8. But if I like do a ping www.google.com, now it's able to resolve a name, and you'll see there's a new connection there for DNS that connected. So my router is connecting to a DNS server. So that is an output chain. So traffic that's leaving from my router out to wherever. And then lastly, we get our forward chain, which I'll just leave it as black because all the other lines are black. And it will be quicker to understand. But now forward is traffic that's being filtered through my router. So let's say this bottom router wants to connect to this other bottom router, but you see it needs to like flow through the network. So it needs to be forwarded through the network. So the destination isn't this router or router one's IP, it's actually whatever IP address is here. The router just knows to forward it through. But this is why you'll potentially be working a lot with forward and input chains. I don't want to say you don't use output chains, but it's pretty rare that people put in output chains. Yeah, that should be the chains. Any other questions? Or are you happy with that answer, Blender? Or did I make it confusing? If I did, I apologize. I don't mean to confuse anybody. Oops, I spilled some water on my keyboard. Please don't break. All right, great. I'm happy if you understand. It's really nice if you take anything away from this lesson. Like it makes me happy. And again, it's not like a lesson. This is just us talking and labbing and figuring stuff out. I mean, you see, like I've even made some mistakes in the lab already, which is great because normal people make mistakes. Life isn't like this perfect 15-minute video showing you how to set something up, because you don't run into those issues in those perfect videos. Okay, next I wanted to talk about natting. Now we've already set up a Nat rule, which was the source-based Nat. I'm going to remove this, and obviously now all my other connectivity is going to stop working. So if I just close this box for, let's go to router 4. I remove that source-based NAT, and let's see, can I still ping 8.8.8.8? No, I cannot ping 8.8.8.8. Why can't I ping it? It's because the traffic is no longer being natted out or masqueraded by router 1, so the internet doesn't see my natted IP. It has no way of knowing how to get to my router's address. Apologies, I just need to cough again. Sorry about that. I did actually have a test done for, you know, the epidemic thingy, and it came back negative. So this is just like the flu or whatever, but still annoying. Okay, so how do we want to explain NAT? NAT is, I think, the biggest reason why we're still running IPv4 networks. You know, these 32-bit addresses that we've got assigned. That's very easy for everybody to understand. I actually think that's also another reason why everybody isn't just adopting to IPv6 immediately, because a lot of people, even though you learn about IPv6 in a book, I can almost assure you, many of you, even myself, you'll study for it for a test, you'll answer the stuff, but how often do you actually implement IPv6 in your network? It's pretty rare, and it should be a major thing because we're running out of address space for IPv4. It's like really it's scary. But because of stuff like NAT, we've been able to prolong the life of IPv4, which is these 32-bit addresses. And now we still get to the internet, and it allows us to effectively, take like this private address and then hide it behind another IP. And I think I did explain it earlier in this IP header business. Again, with NATing, with the source NAT, you're able to change the source address of an IP, and a destination NAT, you can change the destination address of an IP in the IP header. But to fully understand it, let's actually implement some Nat Rules. Yeah, it is actually quite tough, like, because even though I'm sick, I'm still like working my full daytime job, and then then I'm still doing this content as well. I was really half tempted to not do the stream because I felt really bad sounding like I was barking in the last stream, and but I just figured I don't feel that bad. It's just I cough every now and then, so I might as well just get through. Like it's not that bad, and I enjoy doing the streams. All right, let's get back to our natting, and the natting we're just going to be doing on our internet-facing router for now. So router 1. And we're going to NAT stuff to router 4 again. I might as well just remove these other routers, but they look nice in the picture for now. All right. So firstly, we did already implement some source-based NAT rules, but we'll do it again. Just a very simple one. The chain is source NAT. I'm going to say anything that's going out of Ether 1, I want to masquerade. So that's just basically saying any traffic that's leaving over Ethernet 1, hide it behind Ethernet 1's IP address. So if I go back to router 4, let's see if I can ping Google again. Yes, I can ping Google. And that's how easy a source-based NAT is. But that's a masquerade NAT. It might be that you have multiple public IP addresses on a router. Maybe your ISP is generous. They gave you a /29 network, and you're like, wow, I've got these 5 available IPs that I can assign to stuff on my network. And it's so sad actually, because a /29, it's 8 IPs, but you get a broadcast and you get a network address. You only have 6 IPs that you can actually use, but your ISP is going to take 1 IP to give to their equipment. So you actually have 5 IPs, but you're going to assign 1 to your own router. So in reality, you've only got 4 IPs, and that's how quickly we can run out of IPs. But let's say I did have another IP address. So this is actually part of a /24 network. But if I went out to the internet, maybe I wanted the internet to see 150 as the IP address. Instead of 131, the internet will see 150. A good example of this is, let me quickly go to router 4. And let me run a ping to 192.168.74.133, which was router 2's address. And that's obviously failing because of some other filter rules. Let me just quickly see. I might actually just quickly drop all of these filter rules because we're not going to use them now. All right, so now we've got straight connectivity to router 2's public IP address. That's also true. IPv6 is scary in the thought that each address can have its own unique IP for the internet. But don't be too scared, because most ISPs, they'll still use like a private IPv6 pool, which works like our private IPs in IPv4, like your 10 dot whatever or 192.168 whatever, those type of IP pools, and they'll still allocate it to individual machines inside a network and still NAT out as a specific IPv6 address to the internet. Like they'll still do that because our brains are just kind of wired to create networks in that manner. We don't want a random IP that's being assigned via what's it called, DAD or whatever. But yeah, anyways, I'm going off topic here. What I wanted to show you guys was, if I quickly get onto router 2, I wonder, can I check here from, can I do a monitor here? Let's see, IP firewall connection monitor. Print tracking. So this I can only print, which isn't really what I want to do. So I'm just going to open up another Winbox session to router 2. Zoom in a bit. And what I want you to see is, if I go into my IP firewall and I go to my connections, I'm running the ping to 192.168.74.133. So I'm actually half expecting to see the connection here, but right now I'm not. Just want to see why. Else I might just be able to torch ether 1 quickly. All right, there we go. Here I can actually see. All right, we'll do this with a torch. I might just do the torch on router 2. So interface torch. Is it monitor traffic to torch? Monitor traffic. No, let's do tool torch. Interface equals ether 1. Just do that. Oh, but let's just specify some stuff. Let's say we do want to see source address. Wait, I think just like that will show us a source address, won't it? No, it doesn't. Source address equals any distance. Yeah, let's do that. Okay, that works fine. So now we can see connections coming in, from which source it's coming in. Maybe let's just specify the destination address as well, as 192.168.74.133. So the reason I'm doing this is just so that you can see what IP addresses are connecting to my router here. So there is a 131 that router 2 sees, which is correct, because if we go to the topology, 131 is the WAN IP of router 1. So router 2 sees router 1's WAN IP address, but we're actually running the ping from router 4, if I'm not mistaken. Yes, we are. So that's already a source NAT that's happening. But let's say this router 2 was some other ISP, or it's Netflix, or whoever, and we wanted them to see a different public IP. So let's say besides 131, we also had the IP address of 150 on router 1. So here's 150. That also exists on router 1. And what we're going to do now is we're going to add another source NAT on router 1. So we go into our NAT. We add a Nat rule. Let me just quickly read the question. No, question about multiple WAN. No, my ISP gives one WAN IP DHCP. All right, so it's pretty difficult, Ronnie, to just order a single WAN IP. The minimum ISPs might do is like a weird /31 network, but that's still going to be 2 IP addresses, and that might be wasteful. So it depends on how they want to deliver the service to you. Maybe if you have, I don't want to say like more IPs, but maybe you can order like a /29 or a /28 or something from them. If you want to have multiple public IP addresses that you can play around with or NAT with. And I'll show you now how we can NAT traffic out as a specific IP address using this Nat rule. So what we'll do is, this is still a source NAT. So again, we're going to be changing the source address in the IP header. And what we can do is we can say traffic going out, but we could also specify a destination address, which is nice. That's a pretty good network. That's a pretty good size. I mean, what's that? Like 32 IPs. That's fine. All right. So I'm going to say anything that's going out of Ether 1, but I'm going to say the source address is 10.0.2.2, which is router 4's LAN address. I want to source NAT that. So now I'm not using masquerade. Now I'm using a source NAT. Now I can specify what IP address I want to NAT this to. So I'm going to NAT this to 192.168.74. What did I say? 150. Let's just look at the diagram. 150. Yes. So I'm going to apply that. But this definitely works in sequences as well. So I'm just going to move that to the top. And then I want to go to router 4 and let's see if it works. And I've got a suspicion it's not working. Let's see. Router 4. Can I ping? No, I can't ping. But the reason is, and I did explain it earlier in the video, is the IP address also needs to live on the router that you're natting out of. So what I'll do is I'll just add another IP address on router 1. And this I'll statically assign as 192.168.74.150, and I can put it on Ether 1. Well, I don't even need to put in, I don't think I need to put in the /24, but you can if you want to. But since I'm just natting like that, and let's just scroll back, and I can already see it's working. But I want to show you the cool bit. If I go back to router 2, and here is our torch, we can actually see the connection is now coming from 74.150. So now we are hiding router 4's IP address as .150, but the rest of the internet will still see 131 as from router 1. So that's pretty cool. That allows us to do some interesting stuff, especially when it comes to like things like mail servers or whatever, and you might have them connected to something like Mimecast or whatever, and they are expecting to see a very specific public IP address. Then this is how you can NAT that traffic out from that server or device to be that specific IP address. But remember, that needs to be an IP on your network. If you NAT it out as whatever you want, you are going to break stuff because it needs to be able to route back to you as well at the end of the day. All right, so that is a source-based NAT. Now let's do a destination-based NAT. So what I'll do is we'll go into our firewall, not on router 4, we do this all on router 1 because this is where our public IPs are. And then on that same note, I'm going to NAT 150 down to router 4. So to do that, I'm going to go into my Nat Rules, hit the plus. I'm going to change the chain to destination NAT. And now I can say protocol, anything on, let's make it TCP and let's make it SSH again. And we're going to say anything, but we need to specify the destination address, very important. So we're going to say anything that wants to go to 192.168.74.150. We're going to destination NAT that. And we're going to NAT that down to 10.0.2.2. We're going to apply that. And then let's have a quick test. If I do a, besides that, let's actually do a copy as well. And I'm also just going to NAT ICMP down. So ICMP and SSH I'm NATing down. So let's just first see, can I ping 192.168.74.150? I can ping it, it resolves to something. And can I SSH to that? Let's just open up another PuTTY session. So 192.168.74.150 SSH. I'm getting key, so yes, admin blank. and I'm on R4. And that's how easy it is to implement a destination-based NAT. I mean, this is the stuff that will allow you to NAT maybe like SMTP down to a mail server, or some type of application ports to an application server, or if it's your CCTV stuff, you can NAT that down to your CCTV box. It's really that simple. Hang on, I just need to do a quick clearing of the throat again. All right, cool. So that about covers NAT. So we've done filter rules, we've done NAT. Does anybody have any questions about NAT? Also, Ronnie, let me just quickly check your questions again. Okay, I think like the outbound NAT that I showed you is how you can define which IP would be seen as the outgoing traffic. Again, that is being done on the source-based NAT. And there's two types of NAT you can do. That's either the masquerade, where it hides with whatever IP address is defined on the interface, or you can do the source NAT action, and this is where you can specify exactly what the IP address will be that the internet will see, or that whoever will see. Hang on. I should maybe keybind the mute so that it's quicker than going into OBS to mute. All right, I think that about covers NAT. I will continue with the next portion of the lecture, or I don't want to say lecture. It's not a lecture. It's a lab. It's us. This is very informal. I'm not your teacher. You're not my student. Even though I like the dynamic. I like teaching, but I don't want you to feel like pressured in any way. This is a really casual and like open environment. I make mistakes. You can make mistakes. You can ask silly questions. It's all about engagement and just doing the stuff. All right, so Mangle rules. And I've said earlier, this is my favorite part in MikroTik, and I didn't lie. And that is like in the source NAT. If I go back to this IP header, what it looks like. With the source and destination NAT, we can change these details. With a Mangle, you can basically change anything in the header that you feel like, which is really crazy, really cool. So if I add a Mangle, our actions, the list is a lot bigger in regards to what we can do. You can still accept stuff or add it to lists or whatever, but you can do cool things like change the MSS, which is really nice for stuff that if you maybe have like a GRE tunnel running somewhere and you want to change the MSS, this is where you could do that. You could set here also to fast track a connection, but that you could also just do through the filter rules. But the really cool stuff that I use Mangle for quite a lot is the marking. So you could mark stuff. So you could mark a packet, and the packet marking that you do could be referenced in QoS, which is basically the queues, or you could mark routing, which is extensively used for route leaking. And this is it's an advanced topic, but if you start working with VRFs and large ISP networks, route leaking is really important. Sorry, hang on. That felt so bad coughing there. I apologize again. All right, but with the mark routing, we can like do some really crazy cool stuff to deliver services, or for troubleshooting, or just to make something work. It feels kind of patchworky. because you almost feel like you're creating what's it, Frankenstein's monster. You know, you're like bolting stuff together, you're mangling things just to make it work, but it does have an end result, and it does work. It's really nice to have this functionality, because it's very rare. I don't know if you can really do this type of in-depth changing stuff in a packet, like on a Cisco or Juniper or whatever. But here, very straightforward to do. I might need to set up something to explain it a bit better. I don't know if I'm going to like span VRFs or make complex network, but let's do a very straightforward mangle. Let's actually say anything from router 4. Let's create a loopback address on router 2 quickly. So there's going to be a loopback address on router 2, and I want to route the traffic to router 2 without it being in the routing table. This is going to be crazy. So I'll do router 2, quit that. IP address add address 192.0.0.2. That's not on a bridge. Let me just create a bridge interface. Yes, Joseph, the community edition is fine. Like, I labbed on it for very long. I'm just using the Pro edition because I got a good discount during a Black Friday sale for it. I mean, they gave it was like half price, and you get like 6 extra months, so it just made sense for me, since I'm also using this to create content on YouTube. But community edition, you can do basically everything as on Pro. It's just you can't have as many nodes. You know, I think you're restricted to like 64 nodes on a lab. But really, look how much we're doing, and we just got 5 nodes, and I'm really just using 3 of them at the moment. I might even say it's worth more than GNS3, but I don't want to be a like talk down about GNS3. It's because I haven't used it in a while, and I've seen them make improvements to GNS3. I know there's a web GUI for it now as well, similar to Eve, and I'd love to give it a spin as well. So I might spin up some GNS3 again just to see how it functions now. But Eve, it's definitely done it for me. And what I've liked about Eve is how involved the creators are. Like Uldis and Elaine, like they're like the big bosses of the company, and I mean they've spoken to people like directly and helped them with their issues. And with GNS3, if I have an issue, you post in the community forum and you hope somebody helps you. So it's crazy, like the difference in support. I think, like I like Eve, but it's just maybe because of my personal preference. Anyways. Drifting off topic again, I was busy adding an interface bridge name, interface bridge add name, LO0, IP address add address 192.0.0.2 on LO0. All right, cool. So we know that 192. That is not what I wanted to do. I pasted something like in the text. 192.168.74.32. Another nice thing that I maybe prefer using Eve is for some of my members in YouTube, I do share some of my labs so that you can import it on Eve yourself and, you know, play around. And it's also nice for sharing stuff. I mean, I've got plans to create like more MikroTik orientated, like actual like study guides almost for the MTCNA and MTCRE. And I think doing it through Eve with me would be very beneficial. All right, so 192.168, no, not 168.0.0.2. Okay, so that is a loopback address that we've got on router 2. So we're gonna do something crazy with a mangle. And this mangle is going to allow router 4 to communicate with router so you can add the bin image, but you're gonna have to make some changes on how you import the, like you're gonna upload the bin image and then you're gonna like basically convert it to a different format. But there are guides on Eve's website how to do this. Like it's all structured there. Okay, so router 1. I've got no routes how to get to 192.0.0.2, but let's do something with Mangles. Oh, sorry, I've got something in my eye now. That's I'm just not making it now. All right. So what I'm going to do is I'm going to go, and by the way, if you go to IP routes, this rules is a really like, it's really Mangles. It's just a different name for it in a very simple format. But what I'm going to do is I'm going to go into my firewall in router 1. I'm going to add a Mangle rule. And let's do like maybe like a pre-routing, and I'll say anything from 10.0.10.0.2 wanting to go to 192.168.192.0.0.2 action. We're going to route that, and we're going to route that to 10.0.0.1. Now before I add the mangle, I just want to check on router 4. Can I ping 192.0.0.2? No, I can't. I'm just going to add the mangle quickly. And what trickery is this? It's magic. And if you look on, let me go back to router 1. So you just see, and there is packets hitting this rule on the firewall. And if I go into my routes, that route isn't in my routing table, but I'm able to force how traffic is being routed through my mangle rule. I'm telling it before, so pre-routing just means before traffic is routed. And I'm saying anything that's coming from the IP address of router 4 going to that loopback address, I want to route it. I want to push it somewhere, and I'm going to push it to 10.0.0.1. And that is so awesome that I can do that. And this is a very simple example of what you can do with the mangle rule. I mean, like I said, we can do stuff with the VRFs as well. I just want to see, there's also the mark packet, which is nice. So what we could do is we could say any traffic coming from 10.0.2.2 going to 8.8.8.8. UDP on 53. What we're going to do is mark the packet, and we call this DNS. All right, that looks good. So what I'm going to do now is from router 4, let's just quickly set my DNS to 8.8.8.8. Let's do a ping to 8.8.8.8. Okay, now that's failing. But that's failing because we don't have a Nat Rule at the moment. So let's just put the Nat Rule back on. Right. Actually half expecting this to work, but okay. Let me just disable the mangle as well, maybe. Apologies for coughing again, guys. I really feel so bad when I'm coughing. So we're masquerading anything going out of Ether1, which is right. There's no rules here. I can ping 8.8.8.8 from router 4. And I ping www.google.com. I can. So let's turn that mangle rule back on. Actually, let's remove the protocol. Let's just apply that, see if we can mark if we just go to Google's DNS IP. Oh, but in that instance, oh, I'm being silly. Ping 888. All right, now that's getting marked. Because I don't know why I was expecting this IP to get marked, but whatever. So right now we're marking all traffic that's being like referenced for Google. And like I said, the neat thing is we could do stuff like queues, and we could specify some stuff like the packet marks. There's DNS. And here now we can actually like rate limit stuff for DNS. You know, we could change priorities, we could give it more bandwidth, we could give it less bandwidth, and that we're achieving through a Mangle rule, because that Mangle rule allows us to mark the packets destined for Google. I wonder if I should do the VRF bit quickly. Although I've got videos about route leaking, and it goes very in depth. It isn't as short as like some of these quick win videos. But yeah, let's quickly do it, just so I can show you the power of the Mangle again, because it's really nice. Okay, so a good example will be, I'll do Mangle rules on router 4 quickly. And reason I'm doing this is I'm going to add 2 virtual PCs. And these 2 virtual PCs are each just going to connect to router 4 on whatever port. So that PC I'll put on router Ether 3, other PC I'll put on Ether 2. And we'll quickly start them up. Let me just quickly refresh my lab, because I've clearly done something there. And again, guys, I'm not shaming GNS3. GNS3 is a great emulator. I used it for years. I've just enjoyed using Eve recently. I'm gonna say recently, it's almost been like 3 years, but it's pretty good. All right, so router 4, let's just quickly put up a typical network. Let's say that that's a router 4 is a router at a customer site. That's their CPE. And on the CPE, they've got 2 networks. They've got a LAN network, which is running 192.168.0.0/24. And then they've got a phone network, which is 172.16.0.0/25 or whatever. So those are going to be configured on Ether 2 and 3 respectively, but we're going to put them in different VRFs. But this is going to be like a VRF light type of situation, nothing too extreme. And I know I'm like talking things that not everybody might understand. But in essence, a VRF, think of it as, if you look at a router's routing table, a VRF is like having a virtual routing table for an individual service or customer or something, which is very useful, very, very useful. But you don't just need to start putting in VRFs if you don't know what it is. So don't worry too much about it. I just want to show you what we can achieve with a Mangle with a VRF. So what I'm going to do is, I'm just going to add those IP addresses quickly to the interfaces. So I think I said 192.168.0.0/24 was on Ether 2. Oh wait, I'm on router 1 now. I should just go to router 4. So IP address, it's 192.168.0.1/24 Ether 2. And then I'll copy, put ether3 for 172.16.0.1/25. So those are new networks that we've added now for the phones and LAN. And then what I'll do is I'm just going to add VRFs. So here's a VRF LAN. Ether2 will be part of that VRF. And here's a VRF phones. That's Ether3. Now if I go to my routing table, you'll see a few things disappear, but here with this drop-down box, there's a VRF LAN, VRF phone. So you see like it's its own individual routing table now. But I can assure you now, if I go to the terminal and I do a ping, if I ping 192.168.0.1 from VRF LAN, that will work. But if I ping 172.16.0.1, all right, but that's actually working for the wrong reason. It's just working because that IP happens to reside on the router as well. So let's just quickly assign some IPs to our virtual PCs as well. So this is IP 192.168.0.100/24 with 192.168.0.1 as the gateway. And for the phone, I'm going to add IP 172.16.0.40/25 with 172.16.0.1 as the gateway. All right, so from this VPC, which is the VPC for the phone, can I ping 192.168.0.100? I did, yes. Okay, and I can't ping 100. From 100, can I ping 172.16.0.40? No. All right, so neither pings work, and we're going to fix that now by using Mangles. And we can do that by just going to router 4, going to our IP firewall, I'll add a Mangle rule, and I'll say anything before it gets routed from, let's say, let me just say from the, we can do routing mark from the VRF LAN. I could also specify the routing table, I'm sure. Let's do routing table. So VRF LAN, wanting to go to 172.16.0.0/25. What we'll do is we'll mark the routing, and the new routing mark will be for VRF phones. Pre-routing change. Okay, so scratch the routing table. We are using routing mark. Apply that. So anything with the routing mark of VRF LAN, wanting to go to that phone subnet, we'll give it a new routing mark for VRF phones. And similarly, I'm going to need a way back. So I'm just going to go to, let's just close that. I'm going to say anything that wants to go to 192.168.0.0/24. That's in VRF phones. Mark that routing with VRF LAN. So what I'm going to do now is go back to my virtual PCs. Let me see, from the LAN PC, can I ping my phone? I can ping my phone. And from my phone, can I ping my LAN PC? I can ping my LAN PC. So we were able to sort connectivity out between networks in different VRFs by using Mangle rule, which is really nice. All right. That about covers Mangles. So we've done a few cool things with the Mangles. I showed you that we can route traffic with Mangles. We can add packet marks that we can also implement onto the QoS. And we can do stuff like route leaking with the VRFs using the Mangles. And that's what I primarily would use Mangles for. I'm sure there's a few other cool things that you could do with it. But that's typically what I do. And here you can see again on the TOC, there's like a dedicated section just for Mangle, and it will tell you exactly everything that Mangles can do or what the options are when you try and add something. All right. So I've covered the three biggest things that I wanted to talk about on the firewall, which was what the firewall is. Again, you need connection tracking if you want to make use of any of the firewall services. Let me just quickly show this to you guys. So connection tracking, this is enabled by default on auto. You can set it to yes, but without connection traffic, all of the stuff we just did won't work. And I did explain earlier, if you have a fast track rule, it will not be like, none of the other stuff will matter, because the firewall basically ignores whatever you're fast tracking. And an example of this is if I go into my general and I say, let's say stuff to Google's DNS server, I just want to fast track that. That means anything to Google's DNS IP will just get fast tracked. It won't care about anything else. So even if there was a rule to reject stuff, it won't check it, because there's a fast track for that connection now. And that's kind of like why you get improved speed or throughput or whatever to something that you fast track. But it's not necessarily the best thing. And please don't just fast track everything, because it really, the performance boost that you get is really, really minimal. I don't want to say it's not worth it, because you can definitely fast track certain things, but don't try and fast track like everything, because then your stuff isn't going to work, or you won't be able to use the firewall effectively on the MikroTik. You might as well just turn off connection tracking then. Apologies. I feel like there's one more thing I might be able to talk about. If we do a new firewall rule, you do get different connection types. Wait, it's not the connection type. Advanced. I would just like to see the it's not the connection type. I mean, I want to show you the other options for like the states a connection is in, because you get different states. If I go to connections, like you'll see there's a state like it's established, or it's opening, or it's related, or stuff like that. Let's just check here. There's connection state. So connection state is just like obviously when a connection is being made from the router out to wherever, a different router or the internet or whatnot, you get different types of connection states. So established is something that's already connected. It's already able to send and receive packets between each other. New is like, it's obvious, it's a new connection that's being like made. Untracked, related, invalid. I mean, it's very rare that you'll fiddle around with stuff in the connection state, but there are times that you might want to do stuff with all established connections. You want to do something specifically with on the firewall with a Mangles rule. But I would highly suggest you also look at the MikroTik TOC regarding the connection states. I mean, you could just Google it as well, MikroTik connection states. Basic concepts. Here's the nice wiki. And this like very well established or explains like what each state is. All right, well, I can definitely see the stream is also, I don't want to say dying down a bit, but definitely I think everybody's getting ready to either go to bed or sleep or get ready for work or do something else. And we have been at this for over 2.5 hours. And I'm so sorry. I apologize. That was a bad cough. But yeah, I'm probably going to end off the stream here. It was a really nice stream. I just want to mention again, future projects is definitely, I might consider looking at streaming on Twitch, because it might be more feasible for me as a person, or maybe even a business if I want to turn this into a business, to stream on Twitch, because it's just more about a viewership type of deal, and Twitch just caters better for streamers. Um, I am still working on the MTCNA guide. Unfortunately, it's kind of gone on the back burner for a little bit because I've been busy, like really busy with my day job, which it takes priority because it's how I take care of myself and my family and pay the bills. So I can't always commit all of the time I want to just like make a nice guide. But I can give you guys like a little preview again. Like I mean, I've already gotten, I don't want to say 116 pages because these are just like summaries, but I'm definitely getting closer to getting this finished. I mean, I wanted to finish this like mid-June, and here we're in August, almost in September. I'm getting married, by the way, on the 4th of September. So then my fiance will become my wife, which I'm looking forward to. But yeah, this is definitely still a thing. It's still happening. I am working on it. This will be like a companion type of documentation that I'm working on with a guide on Udemy. So there will be some videos that you use with the book, and then you import stuff on Eve. And I feel like it will be a very good like place to learn. I think it's a great place to get everything, all of the information that you want to figure out. Yeah. Anything else that we're planning? Not that I can think of actually. Udemy stuff, maybe the Twitch stuff. What else? And YouTube, I actually feel like I want to also get back to making some YouTube just content, like normal videos. Even though I love the live streaming because, like I said, it's more real because there's mistakes and we get to see how things get fixed. But hang on, I want to see if I can show you guys some of the analytics. Even though it's more of an interest thing, I'm not doing this because I want to brag about anything or anything. It's just I just want to see very specific analytics. Without I think the best way I can show you guys, because I can't really show you through analytics because it has some sensitive information about YouTube that they're finicky with. But if I just go to my channel, right? So just like an example, like these are my subscribers, which I'm very happy with. I'm so happy that I've got this many subscribers. It's unbelievable. But for me, if I just scroll through, like you can definitely see if I stream something, I maybe get like over 500 views for a video. Like some of the streams do a bit better, but it's not like that's sensible for me to like make 3 hours, 2.5 hours, 2 hours, whatever of content, and YouTube doesn't like really care about it because it's fun for me, but it's irrelevant to YouTube. And then on my older videos, like there's way more engagement. Like here's like a City Ansible video, it has 10,000 views. Here's a MikroTik VLAN video, it's got 30,000 views. So this one video has made way more than all of my live streams put together, and it feels like I've put in way more effort in making the live streams than just making a video explaining a very specific thing and just going over it quickly. So there is a good chance I might be going back on creating a just like sorry Just like creating simple or straightforward videos again. So streams will definitely continue, but you might see some more YouTube videos as well. Anyways, that's all the news from me. Again, thank you guys for watching. If you're a subscriber, thank you. If you're not a subscriber, maybe consider subscribing. Leave comments in the videos. It helps a bit with the algorithm as well. And there is also always the option to become a YouTube member. There's some small perks with that, and it does help the channel, like with some cash, like Gavin helped earlier through the evening. He became a member, but it's definitely optional. You don't get out. It's nice that you support the channel, but it's also not a requirement to like follow along. You know, I don't want to push that on anybody. Only support if you're able to, if you feel like the content is worth it. So thank you everybody for watching, and I'll catch you guys in the next video. Hopefully my throat and voice is a lot better next Tuesday. Otherwise I'm going to the doctor again. So see you guys in the next video. Enjoy your day, evening, wherever you are, and have an amazing time. Bye bye.